So today we'll be looking at heat and specific heat capacity. We're going to start by looking at the difference between temperature and heat. So when let's say we have a or container here or pot, it has in water, and we have a thermometer here. So we have a pot of water thermometer here. The temperature is a measure of the average heat energy of the particles present. Sometimes you'll see the definition of a temperature as the average kinetic energy of the particles. So for the temperature, so when we consider the temperature, we consider the different particles present, water molecules. They'll be moving at different kinetic energy. But if you were to take the average kinetic energy of all the molecules, so that is what we mean when we talk about the temperature. It's a measure of the average kinetic energy or heat energy of the particles present. Whereas when we talk about heat, heat is a measure of the total heat energy of the particles present. So if we were to consider the amount of heat present in this pot, we would have to consider each particle and sum up the energy from each. So the temperature is a measure of the average, whereas heat is a measure of the total. All right, so there's a difference between temperature and heat. So let's look at this in terms of a practical example. So here we have two containers. Here is a small test tube with some water, and we have our thermometer, and it measures 90 degrees Celsius. Here we have a flask with much larger amount of water, greater quantity, and this temperature is also 90 degrees Celsius. If we were to pour the content of this test tube onto our block of ice, here we have some ice. This the amount of heat energy from this test tube would not be sufficient to totally melt this ice. Whereas if we were to pour the content from this flask onto the ice, we probably will be able to melt this ice, because even though they both have the same temperature, they have different amount of heat energy. Because remember, heat is a summation of all the particles, the average energy of all the particles. So this has a larger amount of particles, so this would have more heat energy than this content, even though they are both having the same temperature. Okay, so I hope that clarified the difference between temperature and heat. Now, we're going to see how this is looked at in terms of everyday practicality. So first thing, heat is measured in joules or calories. So we have 1 calorie is equal to 4.18 joules. Right. So there's also a specific heat capacity, and the symbol for that is a large C, uppercase C. And specific capacity is the amount of heat required to change the temperature of 1 gram of a substance by 1 degree Celsius. Okay, let's think about this. Have you ever been to on a warm day? So in the night, it's much cooler, and you were to go into a pool. So the pool would actually feel warm, right? Because there's some things that have high heat capacity, meaning that it requires a large amount of heat to change the temperature by 1 degrees, right? And there's some things that they don't keep their heat that long. They they lose their heat energy quickly, or it also there are some things that it takes a large amount of heat. So think about when you put a pot of water, it takes a while for the water to heat up. That's because water is one of those substances that have a high specific heat capacity. If we were to look at the values here, so water has a specific heat capacity of 4.18 versus looking at gold or copper, iron, glass, cement, wood, ethanol. These have much lower heat capacity. And again, specific heat capacity is a measure of the amount of heat energy required to raise 1 gram by 1 degree Celsius. So we end up with a unit of heat capacity. Specific heat capacity is joules, the amount of heat required to raise 1 gram by 1 degree Celsius. So it takes a lot of heat energy to raise 1 gram of water by 1 degree Celsius. All right. So let's look at some application here. Here's a question. Question 1. Determine the heat in joules needed to raise the temperature of 50 grams of water from 60 degrees Celsius to 70 degrees Celsius. So there's a formula we use to calculate heat. So the formula is Q is equal to mc delta theta. Sometimes it's just called MCAT. It's MCAT. This is delta T is change in temperature. C represents, or C is specific heat capacity. Okay, so let's look at this question here. So we want to determine the heat in joules. So that's Q. Q is the amount of heat. Q is equal to the mass, which is 50 grams, times specific heat capacity, 4.18 units is joules per grams per Celsius. And the temperature change is final temperature minus initial temperature. The unit will be C. So if you were to plug these values in, so we would get something looking at. First thing, we could cancel. If we're going to follow the order of operations, we'll always do parentheses first. So it's going to be 50.0 G grams times 4.18 joules per gram per Celsius times 10 degrees Celsius. So we can start to cancel some of these units. The grams would cancel the gram. The Celsius would cancel the Celsius. So we're left with a unit of J. And that's what heat is measured in joules. Heat is also measured in calories as well. But for this question, we are measuring it in joules. So it's 50. If we plug this into our calculator, 50 times 4.18 times 10, we're going to get a value of 2090 joules. So that means it takes us 2090 joules to raise the temperature of 50 grams of water from 60 degrees Celsius to 70 degrees Celsius. Now, how would this be different if instead of 50 grams of water, we had 50 grams of ethanol? So we'd use the same application. We'd use Q is equal to M C delta T. I'm going to, since we have the same units, we know the units already, so we could, for this case, we could ignore the units here because we know what the unit is going to remain the same. So it's going to be 50 times, we'll have to look at the specific capacity of ethanol. Because instead of using water, which was 4.18, we're now going to use ethanol. So we have to look up on our chart, what is the specific heat capacity of ethanol? And we find that to be 2.46. So this is going to be 50 times 2.46. And the temperature change was the same 10. Again, if we were to plug this into our calculator, we'll get a value of 1,230 joules. So here we are realizing that it took us less heat energy to raise 50 grams of ethanol by 10 degrees than it took us to raise 50 grams of water, and that's because ethanol has a smaller heat capacity, specific capacity, than water. So again, we should have some concept of specific capacity is a measure of the amount of heat energy to raise 1 gram by 1 degree Celsius. So you could see that we required much more energy to raise water than it is to raise ethanol. Okay, one other example. Okay, let's say we have this question here. The temperature of a sample of water changed from 25 degrees Celsius to 55 degrees Celsius by the addition of 3,762 joules. What is the mass of the water? We're going to go back to our original formula. Q is equal to mc delta theta. Again, Q is heat, energy, M is the mass in grams, C is specific heat capacity, and delta T is change in temperature. So since we want the mass, we have to get rid of the other component. We need to get rid of the C and the delta T. So we're going to divide both sides by C delta T, C delta T. We're going to end up, the C would cancel, the delta T would cancel. So we have the mass is equal to Q over C delta T. So we could now plug our values in. So mass would be equal to Q. If we look back at the Q we started out with, it was 3,762 joules. 3,762 joules. And C, what are we talking about here? We're talking about water, and water specific capacity is 4.18 joules per gram per Celsius. And the temperature change, T final minus T initial, we started out with 25, end up with 55, so our final is 55. So it's 55 minus 25, that's 30. We could do some cancelling of our units. The joules will go, the Celsius will go, so we're left with grams. So if you plug this into your calculator, we're going to end up with 30 grams. I hope this helped. Good luck.